as we start today, one of the things that I want to encourage you guys to constantly think about is where is the vertex with reference to the circle. So as you guys look at this very first slide here, the key for this is where is the point. Now, it's not meant to be a trick question, so don't overthink it. So the options that you have are on the circle, inside the circle, outside the circle, or is it the center of the circle. So as you look at number one is inside, 2 is on, 3 is the center, 4 is outside, 5 is inside, 6 is outside. Now, some of you guys may be thinking, well, that was pretty easy, Ms. Palmer. When you take a look at the second one, it's the same concept. Where is the vertex? You notice number 1, inside, 2, on, 3, center, 4, outside, 5, inside, 6, outside. And what I've found in years past is sometimes people will look at this screen and say, well, this is easy. But then all of a sudden look at this screen and have a little bit of a challenge. It's the exact same. If you guys notice from screen to screen, it's the exact same picture. It's just that the first one, the dot is where the intersection or where the vertex is located. Okay. Now, the reason that I stress that is when we look at our problems over the next couple of days, the most important question is where is the vertex? That's going to be the key to everything that we do. So as you look at this very first example, the vertex for this is located in the center of the circle. And so as you look at this, we're just going to put center here, and we're going to talk about the relationship of that. And then if you look at the one on the right, this one is on the circle itself. Now, when you have the vertex at the center, the measure of the angle equals the measure of the arc. Okay, and I'm actually going to put the arc here so you guys get used to seeing this label. So in other words, let's say that we know that this angle here in the middle is 95 degrees. Then the arc itself, the measure, not the length, is also 95 degrees. They are equal. Whereas if you look at the one that is on, the measure of the angle equals 1/2 the arc. Or if you think about it the other way, the arc is equal to 2 times the measure of the angle. So again, if we think about this hypothetically, let's make this 30 degrees. That makes this arc twice that amount, which would be 60 degrees. So if it's at the center, they are equal. If it is on the circle itself, the angle is half the arc, or the arc is twice as much as the angle. So let's take a look at some examples. Again, please don't overthink this. Let this be easy. One of the things I want for you to think, though, is always be looking for diameters or vertical angles to help you. So what I'm going to do is in this circle on the left, I'm going to go ahead and label things that I know without answering any questions on the right. So for example, right now I see that I have intersecting lines here, meaning that these angles are vertical, meaning these angles, or these arcs here, are going to be the same. So the 55 degrees here is the same as the 55 degrees there. Now if I take a look at this diameter here, this cuts your circle exactly in half, meaning this side here on the bottom is 180 degrees. So if I do 180 minus 55, that's going to give me 125 degrees here. I could do the same thing for the top half. So the top half, I could, again, recognize the whole thing is 180. So I can do 180 minus the 108 that I know, minus the other piece that I know, that 55. And when I do so, I get a value of 17 for this cut. So as I look at my questions on the right-hand side, what is the measure of YU, arc YU? So that is just going to be right here that I just marked in purple. YU is 17. If I look at XW is here. And so therefore that one is just the 125. If I look at XVW, now notice that this is named with 3 letters. So that means that we're going to have to go over the majority of the circle, or over 180 degrees. That's considered a major arc. So you start at X, you go through V, and you end at W. So that one, we look at this. Actually, let's do a favor and erase the stuff here on the inside just to help us see this a little bit better. So let's do that again. So you start at X, we go through V, we end at W. What we can do is every arc that we just crossed, so the 55, the 17, the 108, and the 55, we can add all those together. we get 235 degrees. Now, someone may say, well, it's everything but this 125. So I can use 360, that's the whole circle, minus 125. You'll get the same answer going that way as well. So take a second, answer the bottom two. Answer what is the arc VW and what is the measure of arc YWU. So take a minute, answer those two in order for us on that number. If we take a look at the second one here, again, what I'm going to do to start is I'm going to figure out the pieces that I don't know. So we look around the outside, I know 68, I know 31, I know 135, so I can subtract that from 360 to get my piece, that GJ, that I don't know. So 360 minus 68 minus 31 minus 115, which is going to give us a value of 146. Now, let's talk about the angles. We're looking here at the angle measures. So we have G to H to J. So G to H to J. Now, think about the arc that is formed in there. So, for example, it's this arc here. Think about if that angle is hugging that arc, or it's in between the arms or the sides of that angle. So, if we look at this, that means to go from the arc to this angle, we have to divide by 2. So, when we do that, we get 73 degrees for that angle measure. If we take a look at GIJ, again, we're going to look at that arc that's in between those sides. It's the same arc, it's that 146. So again, that's going to be 73 degrees because that vertex is on the circle, so we have to cut it in half. Okay, so let's take a look at this one. We're looking for the measure of arc FE. So there's several different ways we can go about doing this. But if we look here at FE, what we could do is we could recognize that we've got this diameter here through the middle. I'm going to make that blue side that blue arc that I just highlighted 180 degrees. The 63, let me erase this blue here. The 63 that's labeled, we have it here and here. The vertex is on the circle, so to go from here to the arc, we're going to multiply by 2, which gives us 126. And so then to come up with the arc FE, I can either do, since we have a diameter going through the middle, I can do 180 minus 126, or I can do 360 minus the whole 2 that I do know. Either way, I'm going to get 54 degrees for the measure of that arc. Now, there's more than one way to do that. There's several ways that I've seen people do that in the past. So when I take a look at the next one, notice this vertex is in the middle. So my angle, that 90 degrees, will also be 90 here, which means all the way around my circle is going to be 360. So I can add all of my arcs that I know. Okay, so I'm just going to go around my circle, making sure that I add each piece and set it equal to 360. And again, there's another way that you could do this. You could subtract that 90 to figure out what the other ones equal. But this is the way that people in the past have made the most sense of it. Okay, so 12 plus 17 plus 2 is going to give us 31x. We can combine my like terms of negative 14, positive 5, and 90, and I would get 81. And then to finish solving, I would subtract from 360, 31x equals 279, divide by 31, and I get an x value of 9. So I would go ahead and fill that in. Arc AD then, I would just go ahead and do 12 times 9. So 12 times 9, 23108. BC, we're going to do this part, so 2 times 9, there, plus 5, so that's going to give me 23. And then again, what I'd like you to do is go ahead and come up with those bottom two. As always, guys, ask questions as you guys are looking at this. Please don't hesitate. If something doesn't make sense, just let me know. We'll plan on doing some examples together in class just to make sure that we kind of drill this home. But hopefully that all makes sense. Let me know if you need anything. Thanks.